Hello and hi. Okay, from this example, is actually from example 1. Okay, let's read the example, the equation first. Consider the function fs equal to x cubed minus x minus 1 equal to 0 using Halley's method and Newton's method to approximate a root function that lies in 1, 2. 1, 2 is actually our a and b. 1a, 2 is b. And accurate to within epsilon 10 power of negative 8. Use absolute FPN less than epsilon as the stopping criterion. Each approximation is rounded to 9 decimal places. Okay, from here, we know that our function is x cubed minus x minus 1. From this function, we need to find the f prime x and f double prime x because for Halley's method, we will use fx, f prime x and f double prime x, while for Newton's method, we will use fx and f prime x to get the answer. So from this fx, when I differentiate, I get f prime x. So when I differentiate x cubed minus x minus 1, I get 3x squared minus 1. And then from this f prime x, I get the answer for f double prime x. When I differentiate f prime x, I get 6x. So if you see here, this is how to get answer for Pn. So Pn minus 1 minus 2f Pn minus 1 f prime Pn minus 1 divide by 2 f prime Pn minus 1 squared minus f Pn f double prime Pn minus 1 f Pn minus 1 f double prime minus Pn minus 1. But this formula only can be used if n more than or equal to 1. And for the stopping criterion, we get the FPN equal to absolute FPN equal to absolute PN cube minus PN minus 1. If you see in this formula, it's actually we get from fx, f prime x and f double prime x. I just substitute x with the Pn minus 1 and Pn here. So in this equation, it mentioned that it's only applicable for n more than or equal to 1. So how to get P naught? P naught is actually we can use any number that lies between 1 and 2. But for this example, I use a plus b divided by 2. So I get 1 plus 2 divided by 2, I get 1.5. And then for absolute FPN, which is our stopping criterion, I substitute this 1.5 in this PN, and so I will get this answer 0.875. And then for this one, 2 FPN F prime PN, if you notice, this is from this above to get the PN. We will use this answer to get the PN for next PN, I mean. And if you can see here, 2 FPN F prime PN. So our FPN is actually from function fx here, function fx. And then F prime PN is from the F prime x. F prime x is 3x squared minus 1. So 3pn squared minus 1. And then for this one, this is from the below here, equation from below here. So f prime pn square. So this one I get from function f prime x. This one, f prime x square. Okay, fpn square minus fpn f double prime pn. So this is the fpn. This fpn I get from fx, and then f double prime pn I get from f double prime x. So we enter. And then to get the next Pn, we can use this formula. So equal to Pn minus 1. So our Pn, if our n is 1, so Pn minus 1 is P naught. P naught is here, 1.5, minus with the previous information of this one, the above one, to Fpn minus 1. So we will get this from this, divided by, this is the below information that we get previously from this one. Just enter. And then since we use Excel, we don't have to calculate one by one, just drag everything. So if you see here, we stop when when we reach the when it is less than epsilon. So our epsilon is 10 power of negative 8. So 0 less than this 10 power of negative 8. So we converge at the iteration at the third iteration. So this is our P3, 1.324717,957. So and then this is for Halley's method. For Newton's method, it's still the same. We get the n, Pn, and then this is the stopping criteria. This is Fpn. This Fpn is actually to get for this one, Fpn minus 1. And this Fpn we get from Fx here. And then F prime Pn we get from F prime x. So in order and this is our stopping criteria. Still the same like Halley's method. We still use the Fx function. Okay. So how to get the P naught? Still the same as Halley's method. So but in this example, I use a plus b divided by 2, 1 plus 2 divided by 2. So I get 1.5. And then I substitute this Pn in this function to get the stopping criteria. And I get this answer. For Fpn, also the same from the function fx, and I get this answer. This is for the above. And then f prime pn for the below. Okay, and how to get the next pn? For the next pn, we can use this formula because this formula applicable when n more than or equal to 1. So equal to Pn minus 1. Pn minus 1 when our 1 is when our n is 1. So 1 minus 1 is P naught, P0. So this is our P0 minus by Fpn minus 1. So this is our Fpn minus 1 divided by F prime Pn minus 1. So this is our F prime Pn minus 1. Enter. So since this is Excel, just drag everything. So we get everything, and we stop when it reach iteration 4, because when iteration 4, our stopping criteria equal to 0. So this is less than epsilon. So we stop. If you can see here, it shows that when we choose Halley's method, we can converge faster than Newton's method, because in Halley's method, to get 1.324717957, we only need to use 3 iterations. But for Newton's method, we need to use 4 iterations to get the same answer. So this is proven that Halley's method is better than Newton's method.